this and this. Okay, so here are the results that like this. Let me see. So these are the steps, the redundant steps. You no need to worry about this. These are the redundant steps. Okay. So it is redundant because of inside the bracket there are 4 terms here. So just now the terms, we always need to open the bracket. So you have 4 terms here, 1, 2, 3, 4. Okay, here I use color. For the different order of derivative. So the yellow one is for the second order derivative of P. Okay. There are 2 terms here. There's only 1 term of second order derivative of P star. And then we have the P over Z in blue, P over Z in blue. And then we have only 1 term of the P over Z. Okay. So we need to substitute all the P derivative and also the P. So we have the PP, the P and P star, and I highlight in gray. So the P must be as what we assume. So after we substitute all this into equation, we won't see P anymore. We will see lambda and phi. Okay. So so here are the intermediate steps. The dp over dz, dp is gamma exponent I omega t, I omega z. So you can work it out. And after this, you cancel the exponent I phi plus kz. So these are the intermediate steps. For the first order derivative, this is the second order derivative. This is the P star, and then this is the d2P over d2P star over dz squared. So after this, I managed to substitute. This is the d2P over dz squared in terms of the gamma. And then this is another substitution. All right. D2P star is these 3 terms. Okay. D2P over dz squared is these 3 terms. Okay. And you have dp dz, dp star over dz. So you have this factor multiplied with this factor. It is in green. Okay. And the last one, now there are many terms. You have this and this. d2p over dz squared. So this is d2p over dz squared. And then gamma. So this is lambda or gamma, I forgotten already. So this is lambda. Is it capital lambda? This is capital lambda. But never mind, you can see, you see this, I might be wrong. So because this symbol, this lambda is real. So P star also carry the same thing. So this you have the lambda square or lambda. So this you have only 1. But here you have 3. Yeah. So that's why you can see this. You have 3 of these. And the rest you have only 1. When you see the P, you have 1. One of this lambda. So is it okay? So this is after the substitution and after the SVEA. There are something that sometimes you need to work out the intermediate. You don't want to directly substitute. It may make you very headache. Okay. You can also substitute directly substitute, but you can always see that the exponent will cancel, because after the substitution, you can see the exponent on every term. So actually, they are the same. So you do this, you get these results in terms of lambda and the phi. Okay, all this lambda and phi. So is it okay? So after the SBEA, why I have this? I think I just copy paste. No, I don't think so. I think I do open the bracket. This is the same as this. This is the same. Okay. And then this, I open the bracket. Okay, I open the bracket. And this one is the same, but this one I open the bracket also. They are different. Here you have positive, minus, but here is positive. Okay, so open the bracket, you have things like this. And after this, just simplify. I hope that you can take a photo of this, see whether you can get the same result, because I think it's true, because I can reproduce the results on the articles. So this is after simplification. I collect the terms with the same order, open the bracket and collect minus, take away terms or something like this. And as I said in last semester, this is the results, and we need to separate into two equations, imaginary and the real. So this is good, because if we use complex, then it is always contain imaginary part and the real part. So this one equation we separate into two equations. Okay, you know why I can do so. Please recall your complex analysis. If a complex number A equals to if complex function A equals to complex function B, so A can be the real imaginary part. B, you have the real and imaginary part. If A equals to B, means that real A equals to real B, and IM A equals to IM B. So it is the same thing. Complex equation, we can always break down to two equations. So this is from the real part. This is from the imaginary part. This is from the real part. So I let it work it out. I let you work it out. No need to further explain, but it's very tedious. You have to be very careful. And the IM part, I can cancel the I. Okay. So for the, after this, you can play around. So this term, I just write this on the right hand